Good afternoon, ladies and gentlemen. Today we will have a continuation from where we left yesterday. So today we are looking at the oscillators. Now, oscillators are a basic source of signals in electronics. So they are used to generate almost any waveform at almost any frequency. Then oscillators are designed in several basic ways. So almost any amplifier can become an oscillator. So when this happens, it means the amplifier becomes useless. Means that an oscillator can work well. So these oscillators, they have got different or maybe several characteristics. And these characteristics, as you can see here, you discover that this is the voltage source. There's a voltage source here, and this voltage source which you see here, the input goes to the oscillator, and this is a grounding. Then you have the output, which is the sinusoidal. So these oscillators, what is we're having here as an input is a DC source, but after the oscillator we have what you call an AC output, meaning that an oscillator can be used to convert or to change DC to AC. Now, oscillators are usually divided into two types. That is sinusoidal and non-sinusoidal oscillators. So, sinusoidal oscillators are usually based on amplifier circuits. A feedback circuit is added to the amplifier so that it will oscillate or produce AC. So the amplifier discussed so far depend on an AC or DC signal arriving at their input. As we can see here, you discover that this is an amplifier, this is a feedback circuit signal. So what it means is that this feedback circuit is used to make an amplifier provide its own input signal. Mean that this amplifier is going to provide its own input signal. As you can see here, that this output, as it comes as a feedback, it enters again through the amplifier. So what you see here, that most amplifiers will oscillate if the conditions are correct. E.g., you will probably know that what happens when someone tunes the volume control too high on a public address system, on a PA system. So the squells and the holes that come out of the loudspeaker are a result of oscillations. So the feedback in this case is in form of a sound wave from the loudspeaker re-entering the system through the microphone as shown here. So what it is that you have an input here. This input goes through the amplifier to the speakers. Then the feedback, now that feedback sound comes again back through the microphone. So that is the feedback signal that we have. As also this one here is a feedback. So this one is just a replica of what is transpiring here, because this is in circuit diagram. So, but in real time, in life, this is what transpires. When you hear those squeals, those things, is feedback entering through the amplifier again. Now, this feedback is in most oscillator circuits is electrical. It is accomplished by resistivity, capacitivity, or inductive coupling between the output and the input of amplifier. This feedback allows the amplifier to develop and maintain its own input. So feedback alone will not generate oscillations. So tuning down the volume control will not stop the PA system from oscillating again. But the feedback is still present. So there is not enough gain to overcome the criteria of an oscillator circuit. So the gain must be greater than the loss. There is one other idea that is also important. Phase. The signal feedback to the input amplifier must be in phase with the input signal. The output must be in phase with the input signal. So in phase feedback is also referred to as the positive feedback or regenerative feedback. When the amplifier input and output are normally out of phase, the feedback circuit you have to achieve a phasal reversal. So oscillators can be made to work over quite a range of frequencies, e.g. some oscillators work in the audio frequency range and others in the radio frequency. An electronic organ uses oscillators to develop the audio signals that you hear. A radio transmitter uses an oscillator to develop the high frequency radio signal. So different oscillators have different requirements. In addition to a frequency, there is also questions of stability. So a stable oscillator will produce a signal of constant amplitude. Now, if we can look, we can check this diagram here. This diagram here, you discover that there is a DC source here. There is a sinusoid oscillator, is grounded well. Now, this sinusoidal oscillator, the oscillators, they have got two types of outputs, basically. So there's one which is sinusoidal. This one is sinusoidal. It is a sine. It produces a sine wave. Then this one is non-sinusoidal, and it has got a square wave. So as you can see, when it entered here, it produced a sinusoidal one. It is sine wave. But this one, which is non-sinusoidal, it has got square waves. So oscillators are of many types and performs many functions. Oscillators produce the radio frequency energy required in radio, radar and TV transmission. An oscillator is also an essential part of the radio, radar or TV receivers used for the reception of these signals. In addition, oscillators have numerous other applications. They are used in test equipment of various types as improved, the servicing and repair of the most complicated electronic equipment. So induction, heating, sorting, sampling, counting, switching are a few examples of the countless functions performed by the oscillators in the industry field. Now, we are going to proceed. We look at the amplifier feedback. So amplifier, to create an oscillator, an amplifier is equipped for a feedback signal. This feedback signal then is amplified and the process is repeated, thus creating an output signal. The feedback signal is in the same phase as the output signal. This signal is called positive feedback or regenerative feedback. Another type of feedback is called negative or degenerative feedback. With negative feedback, the signal fed back to the input is 180 degrees out of phase from the output signal. So what we are talking about here, the positive feedback, like this one here, there is an input signal here through the amplifier output. This is the feedback network. So the feedback network will come through. As you can see here, the feedback signal is smaller than the input which we have here. So for us to have a positive feedback, if we were to know that this is a positive feedback, this signal here, which is the input signal and the feedback signal, they are supposed to be in phase. What we mean by saying they are supposed to be in phase is that, let's check here. This is what we mean by saying they are supposed to be in phase. This one is the input signal, which you see, which has got solid line. You see, input signal. And this one with the dotted lines is the feedback signal. So these, if you can check, they are going into the same direction, meaning that they are in phase. So the output will be the addition of this input signal and the feedback signal. Hence, if you can check here, the output is bigger than the input signal. Why? Because we have added the feedback and the input. Hence, we have amplified our signal. This is where you hear a lot of sound, where you hear a lot of good music, because we are adding feedback signals and the input signals. Then you see yourself enjoying an annual ball, dancing, having that fun because of this is what is happening in those speakers. Then we look at the negative signal. On the negative feedback, you discover that this is the input signal and this is the feedback signal. So this one, for it to be called negative, it is 180 degrees out of phase, meaning that when this one is going to the positive direction, this one is going to the negative direction. So the arrangement is the same, the circuit arrangement is the same, but the behavior of the inputs are different. Behaviors of the inputs are different. What do we mean by saying behaviors of the inputs are different? This is what we mean. This is the input signal. This input signal is in the positive direction, like this is positive direction, but the feedback signal is in the negative direction. So meaning that they are 180 degrees out of phase. This is what we mean, that they're 180 degrees out of phase. So when you check now the output here, you discover that this output is smaller than the input signal. Why? Because we are now subtracting signal A minus signal B. There you can see here, we have subtracted the feedback from the input, hence this one has reduced. So this is about signals and the oscillators, how they operate, how they perform and work. Unless there's any question, feedback, or any clarification where you do not understand. Otherwise, for today, this is the last presentation we are having, and after this presentation, I'll prepare an assignment for you. So after that assignment, then you'll be able to sit for the progress test. Enjoy the day and have a wonderful moments of time.